Assalamu alaikum, guys.
Walaikum Assalam, sir.
Can I start my lecture?
Sure, sir.
Okay. So I'm just sharing my screen. So today, basically, we are working to find the inverter placement, their lengths, and other things, which is basically for the solar plant. It's very important. But we have to require to learn to calculate the cable lengths. So it is very important. So that is why today we are doing, first of all, doing that. Then we move on to other things. So basically, the layout which we have prepared yesterday. So today, first of all, what we have to do, it is basically two strings, two strings. Mr. Kazi, kindly mute yourself. So first of all, we have to like mark the color or anything which will decide that the number of strings per inverters. Like we are connecting the 20 strings per inverters. So here in one block, it should be two strings. So two, this, then this is a four, four plus four, 8 plus 4, 12 plus 4, 16, and then we have this 22. We are just connecting 22. So just changing the color of that one. Block. Okay, okay, okay. By layer, by layer, by block. By so basically, we have to just mark a P line or block, any just finding that like we are uh, marking that one four, then we 4 plus 4 plus this 4, 12, 16. Then we have this one, and this one. Okay. Now it is the one block. Same like that. We will see this one 6. Then we have 8, 16 plus 8, 6 plus 8, 14 plus 8, 22. This one 22. Okay. Now we have again like 8, then we have 10, 10, and then we have 18, 18 plus this one, 4. Okay, so again we are just start from that one, 6, then we have 1, 2, 6, 12, then we have 12 plus 16 plus 4, this one. Okay, so same like that one. We have 8, then we have 8 plus 12, 22, then we have this one, same like that. Just changing the color, this one red, this one should be blue one, this should be global width. We should increase the global width. Okay, no, no. 0.4, this one. Then we have this one, yellow. This is for the identification purpose. And this one, the gray one. Okay, same like that. We will pursue again. This one is the EL. 0 point. Why this one? It should be. Mm, wait, The global width should be like 120. So it should be like 5, and then we have, like 1, 2, 3, 4, 5, 6, 7, 14 plus 14 plus 8, 14 plus 10, 20. So just I'm marking the P line, Y global width, current line width, line width should be, why they are treating like this type of issue. What is the issue basically? Check that global width, P line, the P line, global width, global width, width.
Sir, you can turn off the line weight from the bottom.
Sorry,
Sir, you can turn off the line weight from the bottom. Oh,
this one, I think there are some issue. I'm just don't understand how because its global width should be higher, like 190. Now I have to like specify it 0 global width. Na? When I click on that width, should be starting specify starting width, like okay, ending width specify. Okay, okay. Now it's clear. Okay. So basically, we are start working our. So we have these 10. Then we have this one. Like we have this 10 plus. Okay. We have this one global width 0.3, and we will give them the color like any magenta color. We just give them. So is it okay? Or we still need more inverters? Because I have to give the overview of how we will calculate the length. Is it okay? Or we increase number of inverters?
sir, I think it's enough, sir.
Sir, sir, will you
Yes.
Like, give an overview one time more.
Sorry,
Sir, I said that if it's easy for you, so you can like tell me one more time.
which thing I want to tell you?
The cable size.
Cable sizing? Yeah, cable length.
Sorry, sir, cable length. Oh, actually, I.
Sorry, I'm just going to that. Basically, I'm just marking the area which string we have to connect at once inverters. Like here, I have just connected the 22 number of string in one inverter. Then these are connected at once inverter. These should be connected at yellow one. These are connected at one. And then we have green, this one, at connected at one inverter. So that is why I'm just marking the area. When I will mark the area, I will calculate the length and other things. Basically, it is just for the area marking.
Okay,
Okay.
sir. Okay. Okay.
Hmm, okay. So these. So Mr. Kazi, is it fine? Are we increase more number of inverters? Add.
Sir, it's enough, sir. Enough, sir.
Okay. Now we will make a one block rectangular, like the top view of the inverters. Like we have this inverter, and then we have this like PL. We have we will make a one offset like okay, and then we have V line arc or rotate. Okay, block inverter. Okay, move here. I just like here scale down. Okay, like we are placing the inverter here, or we just move that one to like here. This is scale down, I think. Okay, here we are placing the inverters. Okay, okay. Copy, same one like that. And we are just placing in the center. Then we make the center. Then we are coming at this location. Then we are coming at this location. And then we are coming at that location. Okay. Now we will make stringing like we have these positive, negative. Okay. Okay. Same like that. Copy. Okay. Like here, I will give them. Okay. Now we have two strings here, same like that one. We will copy. Okay. Okay. Now we will again copy. in- Okay. Now we have to copy that one here. We have just scale, stretch up. Okay. Same like that one. Okay. Like here. Then trim command. Okay. Now we will again now we will make, sorry, copy, copy. Now we will make another part here. Okay. Copy. Okay. Same like that. We will copy for these strings. Copy. Okay. So one inverter is completed. Now we'll again copy this one. Sorry, this one. And use that one. Just 5 minutes. I will come back, brother. So here we have make and copy. Okay. And stretch that one. Okay. Mhm. Same one like that. You have to copy that one. See? Okay. And the same one.
Sir, I
Okay.
think just two inverter is enough.
Okay. 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 Just I'm just uh, preparing the things. I think you have get the points. Because Mr. I want that anyone in the class will like fully understand the things. Okay. Okay. Then we have to spread that one. Okay. So these are the strings. Then we have to mark the crunch, like this type of crunch. We have this crunch, like we give them color like red. Same like that for here. We have to mark the crunch for DC. Same like that for the Okay. For the DC, we have like this type of short trenches marking on the layouts. Then we have to mark the LVAC, like we have this LVAC marking. We have this, like here we are reaching this LV. Okay. Same like that. Okay. Offset. Okay. Same like that. Basically, I want that I should stretch. Oh, then we will, like here. Okay. And this one, like again, we apply the offset. Offset. And we have this scale type. Okay. Now we have this crunches marking PL. Like we have this crunch marking. Okay. This should be like a green one, blue one. Okay. Now it is like LVAC, and this should be the MV. Then we have like the same one, MV to MV and other thing. Main purpose is to show how we will mark the trenches, how we will mark the layout. Now we will calculate the length. So we have to like open the Excel sheet one by one. Now it is here we have to like check the length, every length individually, because we don't have any specific commands to calculate the lengths. We just have to check every length, like list command. Just list that and length 30.87 meters. They are if you are drawing in the meters, they will show in the meters. If they are in the millimeter, they will show in the millimeter. So our drawings in the meters. So that is why they are measuring the 30 meters. Sorry, I think units they are meters. Okay. So here is the length of the 30 meters. Like same one, this one. Now again we check that list, this 28.24 length. Okay, we will these will be we will mark like it is string size string 1, it is string 2, string 4. We will mark the tagging on that strings, and then we will calculate the length individually one by one. Like check that length. This is 20.87. Same like that. 18 point length. You have to check that length. 18.24. Same like that. Here I have just this. This is the length. Click on that. 10.87. Same one that 8.24. So here this way we will calculate and check the length every single length with the marking of the string 1, string 2, string 3. Then we will here for the LVAC we also check that list one like 930 33 meters. Here we'll just check that it should be 893 meters. Same one like that. It should be like 863 meters. Here it should be 842 meters. This should be 822 meters. Okay. Uh, then this one will be 801 meters. So basically, this length are the too much because we are installing MV station here and inverter are installed here. But in our actual practical cases, we will mark a small area like 6.6 MVA transformer will be installed there, and so the length of the inverter cable output cable should be as small as possible. Because if we increase the length of the LV cables, it will increase the losses because in the LV voltage are low, so that is why the losses are on the higher side. So that is the process how we will calculate the length. And now, if you have any question, you can ask the questions.
Sir,
Uh,
in this scenario, we
okay.
have to like if the inverter is installed around 100 feet distance, so we have to show 100 feet distance in this diagram also.
Sorry. 100 feet from?
Panel, the
Yes.
DC wire.
Yes. Basically, when you are just placing that inverter, you have to this distance from the edge of the PV module to the back or center of that inverter should be same one like in actual cases. Like here, I just check that one allied distance. This length should be like it should be around 4.5 around 4.6 meters from the edge of the tracker structure to the center of the PV inverter. So around 4.6 meter is the distance. But in actually, when we are placing the inverter, we have to check the actual length, actual width of the inverters, like top view. Here is his depth and his length. So you have to mark the inverter as per the actual size, and then you have to mark the actual length as per your side recommendation, as side condition.
Okay, sir. Okay.
Then you will get the actual length. Because if on actual, I will give you one example like for example, if your inverter is installed here, here, like 20 to 16, 60 meter uh, from the edge of the structure. But in the drawing you have shown here, and you have calculated the length on that basis. But in actual, your inverter is not installed at that location. So your length are not correct. When you get the length and you will prepare the BOQ, or you will prepare the cable sizing, you will prepare the cable schedules, they are not actually an actual, they are wrong one. When on side, when the site team will follow your cable schedules. Their length are not okay, and they will cut the cables. So that is why at the end of the project, your cable will be short. So that is why we have to give the proper coordinate of that the inverter on site. So that is why. So if we have to check the coordinate of that inverter, you just press the ID of that center. Like now you can see that it should be x-axis 66,113,1.04, and Y should be 1858.26. H is 0 because height is 0. So that is the coordinate of that center of that inverters. And you have to provide the coordinate to the site teams. On that basis, they will install the inverters.
Sir, will every time the positive and negative of a string will come out in the same point?
No, no. It basically depends on the topology of the strings. We have three type of topologies. One is that, like I will give you the one example. One is that here I just prepare a one, and okay, copy. Okay. Yes. So like here we are connecting the strings. Now when you will place like a arc, copy, human. Okay. One topology is that. Now positive will come up from this location, and negative will be come up on that locations. Okay. It is a one topology. Now I will copy again, and we will end of that. now this is the positive. Here PL what are there? Okay. We have to skip one panel in between that. This is basically the ending point here, and this should be the second one. Okay. Now this
Yes, sir.
negative to this negative to this positive, then this positive, this positive to uh, this negative. Oh, no, no, basically copy, and we will make them as a this positive to this negative. Okay. Then we will make again this negative, this negative to this positive, and we make again this positive to this, and this positive to negative. Okay. And we make again this negative to this positive, and this positive to negative, this negative to positive, this positive to, and they are like this one. We just have to connect. Okay. Now it's become one leapfrog. Okay. It will be called leapfrog. And another option is that. And another option. Now it should be this one, this, this, and this. Okay. Connected. And they should be connected like that. Like if we have this option, like this type of option. Okay. Now what we will do, just copy this one. This, this. Okay. Copy here and just positive, negative, and here we have to like mirror. Okay. Move, move command. like that one. And PL, okay, same one like that. Copy, 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 okay, here, okay, this one, and this is the positive, this is the negative. So these four topology, the three topologies are used. This is called U shape, U shape. Okay. This is leapfrog, and this is end to end. So here in that case, one length is higher, one is short. In that case, they are almost like 1 meter distance between that, and they are the same length. Okay. It is clear, Mr. Kazi.
Yes, sir. What is the names of this?
Above one U shape, U shape. This one leapfrog, leapfrog,
See,
leapfrog, frog.
leapfrog.
I will mark. Okay, no issue. I will mark U shape. This is called leapfrog, leapfrog, and this is called daisy chain or end to end or end to end. Okay.
Okay, sir.
Right. It is clear now.
Yes, sir.
Yes, Mr. Ahad. Any confusion?
No, sir.
Okay, that's great. So tomorrow we have our last class, inshallah. If you have like this type of question, like Mr. Qazi has sent me in the group that we will do like the lengths and other things. If you have that type of questions, you will raise the in the group. I will totally work on that in tomorrow class. Okay, or we will prepare a one SLD.
Sir,
Sir, sir, please
will you
share
tell
this
us to
document.
Sorry,
Sir, please share this AutoCAD file to the group. And will you please take another class in the protection is 8?
protection. Okay, okay, protection. But I will like arrange on weekend. Okay,
Okay, sir, no issue.
okay. Yes, Mr. Ad.
Sir, will you tell us how to use Microsoft Visio software?
Microsoft Visio.
Yes, sir.
Any specific reason?
Uh, I get to know that it was good for an SLD
No,
diagrams,
no, no, no.
single layer diagram.
Brother, basically, brother, I will totally recommend you don't use any specific Visio or anything. We just use that AutoCAD for the SLD purpose.
Oh, okay, sir.
You, because I have that experience. I have already used Visio and Visio for the SLD purpose. But brother, I will just recommend you, don't waste your time on the Visio and anything. Just use AutoCAD.
For all type of electrical drawing.
Yes,
Okay, sir. Okay,
don't
sir.
waste your time on.
I
Don't
have an
waste your
also
time.
question. Sorry, sir.
Yes.
I'm sorry. I'm interrupting you.
Okay, okay, no issue, no issue.
Sir, actually, I have a question regarding transformer. Literally, I'm getting confused on like the type of transformer. Like there are two types of transformer that we are used in solar, like step up or step down.
Okay.
Is it the client that tell us to use step up or step down, that it's on us to tell them that we are going to use step up or step down according to your wiring?
Basically, brother, it totally depend upon the requirements of the transformer or requirement of the project. Most of the time, like in the Pakistan, you have seen that we don't need any transformer in solar projects because we are just terminating our solar system at 400 volt. And the client also has that 400 volt dB where we will just terminate our output cables. But in case of we have to terminate our solar plant at 11 kV. So like you have seen that in Pakistan, like industrials will install the 1 megawatt, 2 megawatt, and 3 megawatt, and they said that we have to terminate this power plant. POC should be 11 kV bus bar of the in industry main panel. So now what you have to do, because your solar system is producing inverter voltage 400 volt, and you have to terminate at 11,000 volt. What you will do? Now it's my question to you. What will you do? How will you
I will
connect these both?
use I will use a
How
transformer to increase the rating. Step
which rating? Which rating?
voltage.
Yes. Now here you will increase the voltage up to 11,000 volt, and then you can terminate that to that bus bar. So here, what type of transformer will be used?
Step down.
Why?
Sorry, step up, step up.
Yes, step up. So here you will adopt the step up transformer installed. Another questions. You have to terminate your solar power plant at 132 kV. 132 kV. And your inverter output voltage is 800 volt. What you will do? It's question
Step
to you.
down.
800 volt and 132 kV.
Don't know. I think
800 volt means 0.8 kV and 132 kV means 0.8 to 132 kV. So means that you have to increase your voltage level from 800 to 132,000 volt. 132,000. Okay. Here in that case, you have to, because 132 is HV, high voltage, and your 0.8 is the low voltage. So in between, you have to use the medium voltage transformer, like 33 kV, 15 kV, 25 kV, 22 kV. it up to the project and site uh, like site requirement as per the project. So here you will increase in the field from 800 to 33 kV, 22 kV. You will use the step up transformer. And at the substation level, also raise, you will raise 33 to 132 kV. Here also you will use the step up transformer. But in case of the auxiliary, where like the small lights or some fans are available on the substation area, and you have to take power from that substation where you are getting the power from the uh, solar power plant. What you will do? You just use a small transformer, step down transformer, to decrease 132 kV to 400 volt, 132 400 volt, and use that power for the lights and other equipment. So in that case, the step down transformer will be used. So any transformer will be used as a step up and also as a step down, as well as in parallel. They will do both the things, step up, step down. If they are like we are giving at the primary side, primary winding, we are giving them the 400 volt, and they will uh, stepping up the voltage from 400 to 11 kV. And if they get the 11 kV voltage at the secondary, and you have to get the 400 volt, so that secondary become as a primary 130 like the 33 kV, and 400 will become the secondary. So transformer will act as a both way, step up and step down, as a parallel.
Okay, sir. Understand.
Okay. Okay, guys. Inshallah, tomorrow we will meet again.
Inshallah, sir.
Inshallah, sir.
Assalamu alaikum.
Allah Hafiz.
Islam, Allah Hafiz, Allah.